Hello everyone. Today we are here with a new topic of discussion, that is haloalkanes and haloarenes. As this starts with the very first chapter of organic chemistry of class 12th. So here we are covering in this video basic fundamentals of the chapter, what we refer to as these terms, haloalkanes and haloarenes. Halo means a halogen atom, that is chlorine. Group 17 atoms are basically referred to halo, that is chlorine, bromine, iodine and fluorine, etc. Okay, and alkenes refer to the substituent group that is being attached to the halogen atom. Here we are also, it is also called by other names, that is alkyl halides and aryl halides. Okay, alkyl basically refers to the R group, which is non-aromatic, and aryl halides basically refers to the R group, which is aromatic in nature. Okay, so this haloarenes refer to haloarenes which have aryl group as their substituent, that is basically the R group which contains aromatic character. So how are these formed? Okay, we'll go further. Replacement of hydrogen atom in aliphatic or aromatic hydrocarbons by X atom. X is a symbol used to indicate the halogen atoms. Okay, so this is basically the terminology or the definition of the terms haloalkanes and haloarenes. The replacement of H atom in aliphatic hydrocarbons refers to haloalkanes. Similarly, the replacement of hydrogen atom, one atom or other, it may be depends on the compound. Okay, in aromatic hydrocarbons are the one which has aromatic character, that is resonance character. In layman language, if we are to define that, okay, by the halogen atom, that is basically the X atom. So moving further, we have the classifications of these haloalkanes and haloarenes here. The very first classification is done on the basis of number of X atom, that is halogen atoms present in a compound, which is, here we are broadly referring to it as, it could be more than this, but broadly we are covering these three only. Okay, monohaloalkanes, dihaloalkanes and trihaloalkanes. In monohaloalkanes, we only have a single halogen atom which is attached to a R group, or it is basically a aliphatic group. Okay, like say, here we can see that C2H5, it basically refers to ethyl group. C2H5 is ethyl group, and why we have derived it from ethane, which was C2H6, by replacing H atom with this X atom. X could be anything halide, it is basically representing. Okay, and dihaloalkanes, we have two aliphatic groups and we have two halogen atoms attached to an aliphatic hydrocarbon. Okay, like ethylene dichloride, it's basically its common name. And if this x represent chlorine atom, we would refer to it as, in IUPAC name, as 1,1 dichloroethane. Okay, because how let's clarify this name, IUPAC name of this compound, why it is so called. 1 and 1 refers to the position of the carbon atoms to which these hydrogen atoms are attached. We cannot specify this as 1 and this as 2, just because we cannot give it a superiority or preference, because these both the atoms are at equal state. Okay, so we cannot give preference to either of them. That is why we have named both the positions as 1 and 1. 1,1 dichloro, because the two halogen atoms are there in the compound. Dichloroethane, ethane refers to the R group to which these atoms are connected. Okay, similarly we could also see haloalkanes, which is trihaloalkanes. In this we have three halogen atoms attached to three different R group or carbon atoms. Here, if we consider these three atoms, it forms a propane group. Okay, three carbon atoms. If we consider it as an alkane, that is propane. Here the basic fundamental alkane is a propane here, so we will call it as propylene trihalide. Propylene comes from the name by the replacement of three halogen atoms from propane. Okay, sorry, three hydrogen atoms from propane. So this gives us a term, propylene trihalide. Trihalide represents these three halogen atoms which are being connected. Okay, this is the common name, and if we consider the IUPAC name of this compound, it will be 1,1,1 trihalide propane. Okay, so the second classification for the haloalkanes and haloarenes are done on the basis of hybridization. Most important topic we will be covering in the upcoming videos. On the basis of hybridization of carbon atom to which this halogen atom is being attached. So very first is alkyl halide, the secondly is allylic halide, and the third one is benzylic halide. Okay, the halide group or the X atom halogen atom here is connected to alkyl group. Okay, that is R, which is represented by R. It could be anything from methyl to ethyl to propyl. Okay, so here hybridization of the carbon atom to which this halogen atom is attached. Here the hybridization of this carbon atom to which this halogen attached is sp3, because we could see it's sp3 hybridized as it has four different atoms connected to it. That is why we call it as sp3 hybridized atom. If the atom attached to the carbon atom attached to the halogen has an alkyl group attached to it, we call it as alkyl halide. Secondly, allylic halide. If the carbon atom, sp3 carbon atom, hybridized atom attached to the halogen atom is next to the allylic group. Allylic group basically refers to C double bond C group atom. Okay, so this is allylic group. This one is allylic group. Please take a note of it. This one is allylic group C double bond C, because we could see here sp2 hybridized carbon atom is attached to sp3 hybridized carbon atom, which is thereby attached to a halogen atom. Okay, so so basically to sum up, the halogen atom here is connected to a carbon atom which is next to a allylic group. That is why this compound is called allylic halides. Thirdly, moving further, we have benzylic halides. Benzylic refers to this aromatic group benzene, which is derived from benzene, which acts as a substitute in a compound. Benzylic basically derives from benzene, which acts as a substitute in the compound. Okay, so here the halogen atom X is connected to a sp3 hybridized carbon atom which is next to a benzyl group or aromatic ring. Okay, sp3 hybridized carbon atom next to aromatic ring substitute, so thereby covering the entire what do you call bifurcations. So this is all from my end in this video. I hope you guys enjoyed it, and I will be covering more such interesting topics in the next upcoming videos. Stay tuned and stay curious. Thank you very much, everyone.